It's a cold fall day. The clouds have come in following a cold front. Chlorophyll in the leaves has died and disappeared, revealing the brilliant colors of the sunburns that have accumulated over the year. Brilliant yellows, oranges, and reds. And then the leaves fall. Welcome to another Spaces Aces devlog. Today we're diving deep into something new in Unity, and that doesn't have a lot of coverage. Every game at some point has to deal with how users navigate the game or interact with the information the game is trying to give them. To help a user in this case, we create a user interface, aka UI. While trying to continue working on the first level, in particular game modes, I came across the need for a better UI solution so that I may display things like who's on which team, score, and more in a clean, consistent way for the player. Currently I'm using Unity's Canvas system for this. I believe they call this UGUI. The Unity GUI system that utilizes canvases is very much an outdated way of solving issues with UI. It has its uses, like with my world HUD elements and glowing effect of the targeting system, but for cleanly displaying useful information, it has some critical flaws. For one, if I add a new item onto the screen, it may be overlapping with other items. To solve this, I need to manually shift other items out of the way. And items in the canvas have a set resolution because they always need a sprite. And if they're scaled up, they can become pixelated. Other solutions have vector-based options. And for each button or visual element in a canvas, I add another piece of clutter to my scene hierarchy. This is because Unity UGUI uses game objects as UI elements. This is a very straightforward and headstrong method for handling UI, and it's not very efficient. Another issue is that keeping a consistent style is difficult without the use of excessive prefabs and folder clutter, as you will have to manually design each canvas and manually place, size, and color each button and element used. This adds more room for human error, and where possible, it's always good to code away the possibility of human error. This system doesn't allow for it. And last but not least, each item in the canvas is rendered as a texture on a 3D plane. This means that for each item, we have 2 tries, or 6 verts, being rendered and regenerated each time the canvas updates. This is really inefficient in the long run. So what I want is a UI solution that doesn't have these issues. Luckily for me and other devs out there, Unity has been working on a solution for a couple years now, called UI Toolkit. Now before we dive into this kit, let's lay out some learning goals. Let's learn what the kit actually is, and learn how to lay out some visual elements with the UI Builder. Then we can learn how to use style sheets to control the look of visual elements, and then we can get into the code and control individual elements with the code. Then we can look at creating custom controls with the code, and then we'll use transitions and animations to create a clean and appealing main menu with navigation to other menus. So let's start by learning what UI Toolkit and UI Builder are and how they can help us. The UI Toolkit is based on web technologies and exists to specifically solve the issues I listed a minute ago. The web tech it's based on is HTML, XML, and CSS. Respectively, Unity uses what they call UXML, which stands for Unity Extensible Markup Language, and USS, which stands for Unity Style Sheets. The way we're going to create the UXML and USS code is through Unity's UI Builder. So I actually tried to dive into this a few months ago, but I wasn't in a clear enough mind space to learn a whole new system, so I ended up building my UI the old-fashioned UGUI way. I opened it up and tried to place a simple button and couldn't get it to move right, or really at all. So I closed it out and didn't look back until I began asking myself if there was a better way to handle UI. And well, of course there was. I literally turned it down only a month prior to asking that question. So I gave it another chance. And this time, instead of diving in head first and not looking at any resources, I watched a Unity presentation on the topic, and then I opened up an example project. Once I took the time to understand the basics and get the good practices of UI Builder, it became obvious. This is a way better system for creating UI. It's not just more efficient, it's way easier to get an actually good result. Now it's worth noting, at the beginning I learned from an example project, but as I became more confident in the toolkit, I began inventing my own better methods for accomplishing some tasks. This is bound to happen with anything if you work with it critically and you like to optimize your workflow. So let's look at UI Builder now. The way UI Builder works is that you have this preview window in the middle of your UI Builder window. You can set that to match your main camera if you want. This screen is your UXML file. And when you add a visual element, the UI Builder generates UXML code to show that element and position it. From here you can change its size, color, add a sprite, and more. If you get the vector graphics preview package, you can even use those instead of the sprites. I also believe Freya Homer has some vector tools available somewhere. If you just throw a button into the UXML window, you'll have a really hard time putting it anywhere you want to. You can manually tell any item an absolute location to be, but that's not a good practice to get into. The reason for this is that you want your items to interact in accordance with each other's positions. If you have a series of buttons at the top of your screen and you add another, you want all the buttons to adjust their positions to fit the new one. So instead of dragging buttons around and setting absolute locations, we're going to create anchors to use for relative position. So far, it seems the best practice for this is to add VisualElement containers as anchors. So first we'll add a visual element that stretches the whole screen top to bottom and left to right, and aligns itself left to right. We'll call this screen, as it represents our whole screen. We'll also set its size to 100%. Then we'll add a new element for left, center, and right. And now we have those as anchors. So now let's add a button to the bottom left. We can go to the left element, and we could add a top, center, or bottom as visual elements, or we can just start building from the bottom and work our way up if we need. I'll just do that here, since I may never need anything else on the side. Then we can add padding or anything else we need to offset our visuals the way we want. So now we have some visuals, so let's style them. We may want to style this button. We could go into the right panel here and start changing things like color and size, but what if we want all of our buttons to be consistent with each other? This is where your Unity style sheet or USS comes into play. Using style sheets, you can add a class that defines how certain elements should look. The CSS term for these styles are classes. Here, in the builder, they're called selectors. You can also think of them as tags. Anything you tag as header will have a specific defined font, style, color, and whatever else you come up with. Just drag the tag or class onto the item and voila! Your UI is now styled consistently. You can also add multiple tags, so header may only affect the font, but we can add another tag for a button that affects the color and size of our button, and not the text. Then if we add more buttons and tag them the same, we have a consistent style for our buttons. You will notice too that with the default buttons, if you zoom in, they are vector graphics. There's no pixelation. We can also control curved corners or slicing on sprites if we do include a sprite. This gives you really strong control over your game's UI. You can also use the UI Toolkit and subsequent UI Builder to create UI for debugging tools and the inspector if you so please. If we want our UI to appear in the game, we can go to Create, find the UI Toolkit, and create a UI document. Then we select a UXML as our tree. Also make sure you have an event system in your scene if you want any buttons to work. An important element of UI is controlling it with code. So let's see how to control screens with code. This is a pretty important aspect of the UI. I need to be able to tell every label what to say and every button what to do. And it also needs to be able to be changed as information changes. This applies to the way I previously set up my multiplayer. I have all this code that connects people together to servers in different rooms and uses the UI to tell you where you are. But now it's totally wrong because I've changed the way it all works, so I need to rewrite it. One crucial step is getting the information from our multiplayer launcher to display correctly in our new UI. Previously, we could simply define a bunch of game objects and text elements and change them as needed. But now we need to access info that isn't available in our scene hierarchy. Code is the part that held me up the longest in the video because the kit is new, and so people hadn't come up with solutions yet. So I started looking at Unity's example projects, and one thing I found is that MonoBehaviour scripts still work with UI Toolkit, as long as they know to look for the UI document object in the hierarchy. To access elements in the UI, you need to find the root visual element. This is simply the first element that holds all others in the hierarchy. To do this, you can simply say visual element root equals get component UI document dot root visual element. From here, the rest is as easy as root.query or Q, and then the type, and then the string name of it, not including the hashtag it generates. So your type could be visual element or button, or you don't need to list a type if it's just a visual element, and then the name as a string. To test this with MonoBehaviour, I added a clock into my main menu that displays your real system time. I wrote some code to convert this from a 24-hour clock into a 12-hour clock with AM and PM conditions. To get it to display, I just have to query the root element for a label named system clock and tell its text to display a chosen string. This works pretty simply. root.q in carets label in parentheses as a string system clock.text equals our string that we're trying to set. Being an artist first for a long time, it did take me longer than it should have to realize that query was how I was going to access everything in the UI. For a minute, I thought you could only query from a script that inherited from VisualElement and not a MonoBehaviour. So to access an individual element, I didn't know what to do. Well, as it turns out, in a MonoBehaviour, it's as simple as asking the root element for the item you're looking for. So I'm able to find any aspect of my UI and change it instantly since I have access to the root. So if I want to change the displayed version number of the game, I can just say root.q label version number.text equals game version string. This works exactly the same as changing a text component with the old UI system, just instead of getting the component, we query for a label. The old version of this is text.text. Since I can so simply grab an item like this, I can take this further. With some small changes to my old multiplayer launcher, when my launcher script starts connecting to a server, it queries for the main menu manager and asks it to turn on a connecting screen. Then, on connected, we ask the main menu manager to enable the multiplayer menu. This system is so simple, I don't have to actually rewrite any of my multiplayer launcher code, other than getting rid of a lot of game object references that are no longer needed in exchange for queries. I've also learned how to connect other scripts with the code, so now my main menu manager runs the code scene controller equals scene controller .find object of type scene controller. With this, we can now set UI functions to control what scene we're in. I use this to set up a quick way out for players. You can press the exit button and the game will turn off if it's a build. This is also how I get the UI to talk to the multiplayer launcher. Let's actually dive into this area a little bit further since I didn't explain what my menu manager was. To control the UI from the root, we need to make a custom control to manage all the screens and buttons. For me, this is called Menu Manager, and is a normal CS file. When you edit the script and you want it to appear as a custom control, you do need to do a few things. 1. At the top you need to add using UnityEngine.UI elements. Then, instead of inheriting from MonoBehaviour, we should inherit from VisualElement. This will make our code an actual visual element. Third, to have the control appear as something we can use in the UI Builder, we need to add these lines of code. Public new class UXML factory, UXML factory, and then the name of your script, comma, UXML traits, and then these silly little curly braces. And then public new class UXML traits, VisualElement.UXML traits, and then more of those silly little curly braces. These can hold some custom data, I believe, but I don't need any for now, so they're just required to get the control to appear correctly. And 4, we need to actually initialize this code. Here we create a public and then the name of our class, for me, menu manager, so it's a public menu manager. And inside this, we want to register the callback geometry changed events. Then we create our function for onGeometryChanged. And now we can make this code our root object for the UI document. Create a UXML and apply Menu Manager as the first item in the hierarchy and make that UXML the tree that the UI document is looking for. Now we should be able to affect our screens with code from our Menu Manager. And we should be able to ask our Menu Manager to affect our screens based on code from other MonoBehaviours in the UI document. So if we go back into our Menu Manager and look at onGeometryChanged, here we can assign screens and run all of our code for our buttons. When you click on a button, onGeometryChanged is run, allowing you to then check which button was clicked. To find which button was clicked and run a function, we once again use query. Since the script is our root object, we can simply tell a button to run a function by saying this !.q, let's say return a home screen, !.register callback click event, and then we say our event leads to enable home screen. And then we can have a public void enable home screen. To enable and disable elements in the UI document, we'll be changing the display style between flex and none. So in enable home screen, we can say homebuttons.style.display equals display style.flex. Now that enables the home buttons, but we also want to disable all other elements. The Unity example projects did this in the individual functions for each screen, but I've chosen to split mine up a little. Some things I know I want to manually choose when they enable and disable, but some I know I only ever want to see on their appropriate screens, so I found it more efficient just to create a function called disable all screens and run some code to disable each element, and then on the individual functions to activate elements, I just write in each element I want to reactivate. This shortened my code significantly. So now if we click the button called return to home screen, it will run the function enable home screen and then disable all screens and then enable the elements that make my home screen work. This is the part where things start becoming more powerful and more efficient. Now with Query, I can start coding by simply searching for what I need to. I can ask if my connect to random room button has been pressed, and if so, I can ask the multiplayer launcher to connect me to a random room. Then the multiplayer launcher asks the UI to display that I am connecting to the room. Then once I'm connected, the multiplayer launcher can check if we have enough players. And once we have enough players, it can send a message to the UI and start a countdown. Then once that countdown reaches 0, it can load in everyone into the same scene. Since the multiplayer launcher is a MonoBehaviour, I can start a coroutine to count down, and each second I can have it change the string of the label that it uses. You can use the custom control code to do more than manage the menus. I wanted a control that defined how profile information was displayed as a nameplate. So I set up my code, and added in images and labels to represent the data that I wanted. Then I added styles with the code. So I created a reference for an image, then I created my image using my image equals new image. And then I added the image simply using add.myimage. And this added it to the root that this class is based in. After some tweaking and setting up the styles and getting the sizing right, I eventually had a profile nameplate that appealed to me. So now let's talk about pseudoclasses, transitions, and animations. It's hard for someone like me who isn't trained at all in UI to create the perfect UI in one go. So at some point I'll have to call it for adding new elements and constantly changing the UI. But before I finish up and call the video done, there is something that has been bothering me. Ever since I added my own style to the buttons, I lost the change of color they get when you hover over them with the mouse. For a while this has been frustrating me in the background, and I've been telling myself I'll cross that bridge sometime before I end the video. Well, that time is now. I went and took another stroll through Unity documentation, and I found what I'm looking for. Every class in the style sheet or .uss file can be linked to a certain pseudoclass. This is controlled by typing the class name pseudoclass name when you create a selector. In CSS, pseudoclasses are built in and describe certain conditions. In Unity, it works the same, though we have a few less than CSS at the moment. Here are the pseudoclasses currently provided by Unity: hover, active, inactive, focus, disabled, enabled, checked, and root. Each has a different condition that would allow the pseudoclass to override the main class. So for example, if I were to take my button class for the multiplayer button and add a pseudoclass that turns it yellow when hovered, then while my mouse is hovering, the button will turn yellow automatically. Convenient, isn't it? Most of these I feel are self-explanatory. If you need a more in-depth explanation on the other pseudoclasses, you should be able to find the manual by looking up Unity UI Toolkit PseudoClasses. Something I noticed while trying to add the pseudoclasses was that the hover capability would not work in play mode. For whatever reason, it only seemed to work in preview mode. I eventually found out that the answer was I was using the event system for UI input, but it was the one for Unity's old UI. So I simply needed to replace that component with the one designed specifically for UI Toolkit, and now it works as expected. Now this isn't actually a problem anymore in Unity 2021.2, which contains the first supported build release of UI Toolkit. I actually ended up upgrading my Unity to 2021.2, not for this reason, but you'll see why in a second. Having gotten pseudoclasses working, I thought this would be a great time to end the video. But then, I found out something new. In Unity 2021.2, they fix a lot of bugs I've been having with UI Toolkit. That's one reason why I upgraded. It's considered a supported release and no longer experimental, but another big reason is because they added transitions to the styles. I was going to cut the video saying I didn't get to animations, but this will cover some basic ones really easy. For example, we were about to end with me having created a pseudoclass for hover. Now in that pseudo class, I can add some scale and set a pivot point, and then in the base class, I can add some transition time. And voila, just like that easy, we have a very simple animation that tweens from the smaller size to the larger size whenever I hover, and increases the feedback and professionalism of our UI, and does so with some truly minimal effort on my part. So long gone are the days of storing animation files throughout the project. Quickly experimenting with this, using the pseudo class for disabled, I can move this panel out of the way when it's unusable, and pull it back when I'm ready to use it. It's not too great, so I took a small break and came back ready to see if I can take this further. In looking further into the Unity documentation, I found some important events. One really important event is the transition end event. Using the styles, we can create a selector. I call these selectors animation classes. And using events, we can time actions to play out in relation to our animations. For example, if I click on the start screen, I want the title to fade. And after it's finished animating, I want to enable the home screen. To do this, I can create an animation class, opacity out. And on the click event, I can add the opacity out class to the title screen. This will trigger a transition to a clear screen, and then I can have a listener for transition end event on the title art. This means that when the title screen has fully transitioned to my opacity out animation class, we can run the function enable home. The code looks like this. Got my title screen, register callback click event, and then we query my title art and add to class opacity out. Then, on my title screen, we register the callback for transition end event, and when the transition's over, we enable home. I can animate using transition time without adding classes as well. To do this, your object simply needs transition time. You can also set that in the code. And then you need to define a change. You can manually change opacity with code, for example. At one point, I created this progress bar to keep track of progress when connecting to the servers in my game. This bar starts with a width of 0%, and I change it to 100% when you're finished connecting. I also have some other numbers in between for each part of the connecting process. Each time the number changes, the transition time automatically tweens between our previous width and our new width. And then once the number reaches 100%, I tell the code to open the multiplayer select menu using the transition end event. That way the bar always finishes animating to 100% before the screen switches. At this point, I've explained all my main points, and hopefully didn't miss on anything crucial in explaining the process of the weeks of research I put into this, so hopefully you can skip much of that research process. I do, however, super highly recommend giving the documentation a good read on your own, as I certainly didn't cover everything, just enough that you can get a professional looking start on your own. In the next one, I hope to finally work on creating the game mode system. That requires UI, so if I learn anything new about the UI Toolkit, I'll share that in the next log. Until then, make what you need to make. Try to never look back at UGUI if you can help it, because this UI Toolkit is the future of Unity UI. The only thing it really can't do is give you world space UI, but you can use code to match screen position to world position. And I don't think you can affect the UI with post-processing like I have here with my glow effect on the UI, but I also haven't tried it yet. Alright, well that's the end of the log. See ya. Hey folks! This video is pretty much 3 weeks of research crammed into one video. UI Toolkit is very much a new feature to Unity, and thus there isn't a lot of good information outside of Unity documentation about how to use it. So everything I learned was through Unity documentation and Unity example projects. This video went through my process learning it, and should hopefully give you watching a head start on figuring it out. If you need to, go back and take note of specific code snippets needed to accomplish tasks in UITK. I should have hopefully showed enough of my code as I went that everything you need to accomplish what I have can be done. A recommendation I have is a program called Obsidian. I've been using that to take notes and build my own personal documentation for how I understand systems and code. I also wrote my script for the video in Obsidian. Having your own explanation of these systems and code in your own documentation and why it's useful to you is really useful for grasping new concepts. Anyway, I hope I've helped, and thanks for watching. Subscribe for insight into my upcoming game mode system, hopefully. And see you in a few.